All right, y'all. Today we are going to practice FRQ so that we are ready for them on the AP exam. This FRQ is mainly fundamental theorem of calculus and what I call graphical connections. Usually on the AP exam, your FRQ will have like a certain theme, like a question stem is what it's called, and then it'll kind of use different topics in calculus that you've learned to kind of assess how you can apply those skills to that theme. So today's theme is fundamental theorem of calculus, graphical connections. All right, every FRQ on the AP exam, you have 15 minutes approximately to complete. So this video may be a little bit longer than that because I'm like explaining each step, but I want you to keep in mind as we go that you would have to work quickly because you would only have 15 minutes to finish this entire question. All right, let's get started. Please do this in your notebooks. Take notes as if it's like notes, and then you will get a practice or an opportunity to practice fully on your own and see how you would do on a question similar to this one. Okay, let's start by reading the question. The graph of the function g consists of a quarter circle and 3 line segments shown at the right. Okay, so the first thing I'm going to do, this says g is shown at the right. The first thing I'm going to do is label this graph as g. Even if it had already labeled your graph as g, I want you to relabel it because it's good to remember what the graphs are. A lot of the time they'll give you multiple functions. For example, let's keep reading. Let f be the function defined by this equation. F of x equals the integral from -1 to x of, and then this is our g function right here. Okay, so we've got two functions. It's good to keep them straight. So that's why we label the graph. Okay, cool. So now for part A. Part A, find f of -5. Part A should be our easiest question on this FRQ because all we have to do is plug in -5. So where do we see, or where do we plug it in? We plug it into the parentheses here for x, and where do we see x? Right there. So we're going to plug in -5 for x. All right, so f of, I'm going to do my -5 in a different color, equals the integral from -1, plug in -5 for x, of, and then I'm going to do this in pink because this is our g function, dt. Cool. All right, now obviously we're going to want to evaluate this integral, and we can use the graph to do so, but there's something that we should notice when we're looking at this integral. Something's not quite right. We're not ready to take the integral yet. We need the boundaries to go from smallest to largest. Right now, it's -1 to -5, and -1 is not smaller than -5. So what do we do about that? How do we flip it? You put a negative out in front of the integral symbol, and then you can flip your boundaries to make them smallest to largest. So we have negative the integral of g of t dt, or the integral from -5 to -1 of g of t dt. Okay, now we need to use the graph of g to find the integral, and the integral just represents the area. So let's go ahead and write equals. Remember your negative sign that you had out here, so we're going to do negative, and then we're going to find the area. So I'm going to put a parentheses. That's going to be the start of our area. And now let's find our area. So we have to find the area using shapes that we know the area of. We have a quarter circle here. We're going from -5 to -1, right? So we have a quarter circle. We have a triangle right here. And then we have another triangle right here. Now, we can see right now that these two triangles, this triangle and this triangle, they're like the exact same shape, right? One's above the x-axis, one's below the x-axis. So this is like a positive area, this is a negative area, and they're the same number. So those are actually going to cancel each other out. So you can like see that right away. You can see that those two areas are going to cancel each other out. I can like show you though, I can show you how they cancel each other out with the math as well. But like really, I wouldn't even write the math for those. Okay, so let's do our area of the quarter circle. Area of a circle is pi r squared. So a quarter circle would be pi r, our radius of this circle would be 2. So 2 squared, and then divided by 4 because it's a quarter circle. Cool. So that's the area of the quarter circle. And then you do plus the area of the first triangle, which is 1/2. Base is 1, height is 2, so 1 times 2. And then because this is below the x-axis, that pink triangle, it's minus, and then it has the same base as the other triangle and the same height as the other triangle. So minus 1/2 base of 1, height of 2. And then you can see that these two areas, that's the same. It's positive and then minus the same numbers. So those are just going to disappear. Those like cancel out. And we get equals. Normally, I would not simplify this. Normally, I would just leave your answer like this. So actually, let's box this. Eventually, we are going to have to simplify for part D, but we don't know that yet. So let's pretend we're taking the AP exam and we're trying to save time. And let's box that answer. Okay, cool. Let's move on to part B. Find all the values of x on the open interval -5 to 4 where f is decreasing. Justify your answer. Okay, so if we're looking for where f is decreasing, we are going to need to know our graphical connections. We see that word f is, or that phrase, like where f is decreasing. Let me underline it. And we should write down instantly our justification. Remember how we like start with justification and then do the actual math? So part B, graphical connections. F is, or you could say f of x if you want, but you could just say f. F of x is decreasing. And these things are things that need to be memorized if what's true. Now, I have them over here. They're on your reference sheet. So if you want to like study your reference sheet, that would be a smart thing to do. You are supposed to know all of these graphical connections like in your head, in your heart. But if we're looking for f decreasing, right? So f of x is decreasing if f prime of x is less than 0. So that's what we're going to write. If f prime of x is less than 0. Or you could like think of it as f prime of x is negative, right? That's the same thing. Those are saying the same thing. So you could write one, either or. Okay, so and then just as a heads up, this chart says the same thing. So if you want to memorize this chart instead, you can f of x is decreasing if f prime is negative. Cool. All right, now let's go back to finishing this problem. We need to know where f prime of x is negative. So do we have f prime of x given to us in our problem? No, we don't. But we do have f of x. We know f of x, so we can find f prime. So I'm going to rewrite f of x right here, and then I'll find f prime. F of x is the integral from -1 to x of g of t dt, right? So f prime of x, we can use our fundamental theorem of calculus. Remember, when you're taking the derivative of an integral and you have a function in the upper boundary, we can just plug that function in. So it's g of x. And then times the derivative of just x, but that would be just times 1, right? So we don't need that part. Okay, so now we know that f prime is g of x. So how did that help us? Well, we needed to know where f prime is negative. This is the same thing as saying, so like let's go over here. So we're going to write the equivalent statement. So f prime is the same as g of x, right? So where g of x is negative. Like I can replace those, f prime equals g of x. So we need to find where g of x is negative instead of f prime is negative. Those mean the same thing. So where's g of x? Well, that's our graph. That is our graph right here. So we just need to figure out where that graph is negative. Remember, negative means below the x-axis. So where is g of x below the x-axis? Right here. So from -2 to 1. And that's what we're going to write for our answer. So we will conclude. So we can just like say it down here. So So f of x is decreasing on, it was negative 2 to 1. Negative 2 to 1. You could also write negative 2 is less than x is less than 1, but I like interval notation instead. Okay, sweet. Let's see if I can erase these real quick. Actually, I guess it doesn't matter. Cool. Let's move on. Let's go to part C now. Part C. Write an equation for the line tangent. Okay, when we see these words, equation for the line tangent, before you even like read the rest of the question, I want you to write the things that we know we need for the equation for the line tangent. We need the equation of a line, so y minus y1 equals m times x minus x1. And then we need a point. Remember doing this? And we need a slope. Okay, these are the things we need to actually do part C. So now let's keep reading. Write the equation of the line for the line tangent to the graph of f at x equals negative 1. Okay, so it wants us to write the equation for the line tangent to f. So like that's our green function at x equals negative 1. So to find our point, we're going to have to find f of negative 1. And then to find our slope, we're going to have to find f prime of negative 1. Cool. Now we have f of x right here. Remember, f of x is right here. So f of negative 1 would just mean plug in negative 1 for the x. So we get the integral from negative 1 to negative 1 of g of t with respect to time, which would equal the integral of from the same to the same. That's going to equal 0. So that integral equals 0. So let me put that here. And then f prime, y'all, didn't we just write what f prime of x was? F prime of x is the same as g of x. F prime of x is the same as g of x. So f prime of negative 1 equals, that's the same thing as g of, oops, sorry, y'all, negative 1. So what is g? G is the graph. So we need to go back up to our graph and find what is g of negative 1. So like at x equals negative 1, what is my y value on that graph? So g of negative 1, here's my point. What's my y value at that point? Negative 2. G of negative 1 is negative 2. So we have negative 2 here. This is our slope. So actually, let me just do this in this color, negative 2. Okay, cool. Once you get your point and your slope, oh yeah, by the way, if you're like still kind of not sure about our point is the point negative 1 for x and then 0 for y. And then here's our slope, negative 2. So we have our point, we have our slope. Now we're ready to plug in to this equation and then isolate y. So let's go ahead and do that. Let's take this equation over here. Oops. Honestly, you could also, here, let's just bring it down here. So we get y minus y1 is 0. And then equals, the slope is negative 2. And then we have x minus x1 is negative 1. We need to isolate y. Luckily, it's kind of already isolated because it's y minus 0. So it's just y equals negative 2 times x plus 1. Please don't do any more simplification than this. Don't distribute the negative 2 if you don't have to. This is the equation of a tangent line to f at x equals negative 1. All right, let's do part D. Part D. We have another keyword, another calculus keyword. I'm trying to pick a color. Find the, I don't like this color. Sorry, I'm being really picky, y'all, because I'm trying to like make it obvious where I'm looking for things. I'll just use orange again. Okay, find the minimum value of f on the closed interval negative 5 to 4. Okay, so minimum. That's a keyword, and that's another graphical connection keyword. So let's go over here. We need to memorize these. But when does f have a minimum? F has a minimum when f prime changes negative to positive. That's when f has a minimum. So let's write that down. D, part D. Okay. F has a minimum. F has a, you can write min, if f prime of x changes negative to positive. All right, cool. So again, we need f prime of x. We need to know when does f prime change negative to positive. F also could have a minimum at endpoints. Remember how we talked about if it doesn't say relative minimum, then it means absolute. So when it just says like find the minimum, that's actually asking you for the absolute min. So that means that we need to check our endpoints. So f has a min if this is true or at the endpoints. We don't know where the actual min is, and we don't know what the min is. And if you look, this question is asking us for the minimum value. That's the y value, y'all. But we're always going to write these problems in a certain way to where we like get them right. So I'll like help you out with that in a second, or like after we do the math. But let's go back down here. So we need to know where f prime changes from negative to positive, or we need to know about the endpoints. So first, where does f prime change negative to positive? Well, if we recall, we need this statement again. F prime is the same as g. We found that earlier, so let's write it down again. F prime of x equals g of x. So this thing could be rewritten as g of x changes negative to positive, right? So we need to look back at our graph and figure out where does our graph change negative to positive. So let's go back up and do that. Oh my goodness, this keyboard. Okay, where does the graph change negative, that means below the x-axis, to positive? Negative to positive at x equals 1. So let's write that that happens at x equals 1. So at x equals 1. And then, and our endpoints are what? Let's go back up to our question or the graph, but our question actually tells us the endpoints. It says on the closed interval, -5, 4. This also tells you to include your endpoints because it has brackets. See how it has brackets? So that means you need to consider your endpoints when you're trying to find this minimum. So -5, 4 are at x equals -5 and x equals 4. That's where our endpoints are at. Okay, so what do we want? We want to find the minimum value of f. So what we need to do is we need to find f of all of these x's. We need to find f of -5. We need to find f of 1. And we need to find f of 4. And we need to figure out which one is the smallest value. And then we're done. We need to find the minimum, the actual minimum. So the good news is we already plugged in -5 into f. Remember how we did that up here in part A? Check it out. F of -5, that's what we found in part A. So f of -5 is this thing. And remember, these like cancel each other out. So we're not going to actually write those. We're just going to write this, the negative sign, and then this guy. So let's write that. -pi 2 squared over 4 equals -pi 2 squared over 4. Let's simplify. Equals 2 squared is 4 over 4. That just is -pi. All right, so we got f of 5. Sweet. How do we get f of 1? Well, we have to plug in to the f function. So actually, let me like remind us what that is so we can like look at it while we plug in. So remember, f of x was the integral from -1 to x of g of t dt. So that's how we got f of -5. Now let's find f of 1. That's the integral from -1 to 1 of g of t dt, which that means we need to go back to our g-graph and find the area from -1 to 1. So let's go do that. -1 to 1. From -1 to 1, we need to find this area. And that would be 1/2 base. It's negative, by the way, because it's below the x-axis. And then so -1/2 base of 2, height of 2. So equals -1/2 base of 2, height of 2, which equals -2. Right? Okay, and then now let's find f of 4. F of 4 equals the integral from -1 to 4 of g of t dt, which equals, now we need to find that area from -1 to 4. We know the area from -1 to 1, so we can actually use that. It would be -2, and then we would add the area like from 1 to 4. So we already like found this. So now we need to add the area of this. So that would be 1/2 base of 3 times height of 1. Base of 3 times height of 1. So 1/2 base of 3, height of 1. Cool. Let's simplify. So equals -2 plus 3 over 2, which equals, if we want to add the fractions, we need a common denominator. So that's -4 over 2 plus 3 over 2, which equals -1 over 2. All right, what were we trying to do again? We were trying to find the minimum value. So what is the minimum value of f? What is the smallest of all of these numbers? -pi, -2, or -1/2? -pi, that's -3.14. That is the smallest value on f. So here's how we're going to finish this problem. F has, we're going to answer it like this every time when you're asked for max or min. F has a minimum value, value of -pi at x equals, what was the x value that we found that minimum at? X equals -5. Boom. There's our answer. So the minimum value is the y value. That's the y value. And anytime you're asked for the minimum value, you have to compare all of the y values. So like we did -pi, that was a y value, -2 and -1/2. We compared them and we found -pi to be the smallest one. All right, this would be a 100% on this FRQ. A 100% on an FRQ is 9 points. So on the practice FRQ that you do, you're going to grade yourself out of 9 and see how many you did. I want you to do your best to try to complete each FRQ that you practice in 15 minutes. But if you need to take longer, make sure you finish it anyway. And then we will get our practice time like perfected before the AP exam. So yeah, good luck practicing, y'all.